going to do the same thing that we've been doing with one final or last twist to it, and that is evaluating a specific x value. So we're going to go in and do our derivative, use our definition of the derivative formula, work through, and then come back and plug that value in the end. I'm going to work through this one and then maybe the first two or whatever, and then instead of me talking through them all the way, I'm going to have you pause the video, work through, get your derivative, and then come back, turn it on, and then we'll re-meet it, or we'll get, meet back together and then do our final step together. But remember that I've got my function, and then I need to write this as f of x plus h, so in this case it's 2 over x plus h minus 1. And then I'll put it into my derivative formula. F prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. And again, I need to simplify. If I were to take the limit the normal way, I would end up with 0 over 0. And so I need to do something algebraically. And at this point, it really is a matter of who your teacher was, and there are a lot of different ways to simplify this. One way is to work with the fractions here, multiply each fraction within there by the common denominator top and bottom. But another way, because it's a whole fraction, is to multiply the top and the bottom of the fraction by the common denominator to get rid of the denominator. And so I'm going to do that method today, where I multiply the top and the bottom by x plus h minus 1 times x minus 1, x plus h minus 1 times x minus 1. And again, there are multiple ways to do this. This is a way. If you have a better way or a different way, feel free to do it. It's the end result that we're looking for. When I do it with this method, what happens is the first fraction, the x plus h minus 1, cancels out, and I'm left with the limit as h approaches 0 of 2 times just x minus 1. And in the second fraction, the denominator, x minus 1, cancels out, and so I'm left with minus 2 times x plus h minus 1. And then that would be all over the h times x plus h minus 1 times x minus 1 denominator that I multiplied there. So again, just a different way of doing it. There are multiple ways. This, I think, is a pretty efficient way. So then I can do the cleanup, the limit as h approaches 0 of 2x minus 2 minus 2x plus, no, minus 2h plus 2, sorry, over h times that common denominator. And then I can do my cleanup, cancel stuff out. I'm also left here with, on top, I just want to kind of highlight with it what I'm left with on the top, that minus 2h, and that h on the bottom, the h's can be canceled out. So now I have the limit as h approaches 0 of negative 2 over x plus h minus 1 times x minus 1, and then when I do my limit by plugging that in for the h, that term would cancel out, leaving me with negative 2 over, remember yesterday this is x minus 1 times x minus 1, so we write it as x minus 1 time, or x minus 1 quantity squared. So there is my derivative. I say f prime of x is equal to negative 2 over x minus 1 quantity squared, but I need to find at x equals 3, so what I do is find f prime of 3, and that just means I plug in 3 for that, 3 minus 1 squared, leaving me with negative 2 over 2 squared, which is 4, or negative 1/2. That means the slope of the line tangent at x equals 3 would be a sort of flat-ish negative slope. So it would be down 1 over 2, so it would be a line that would have a sort of kind of, again, flat negative slope to it. The tangent line would have that look. So that must mean that the function at that point is decreasing, but it's not decreasing at a very fast rate. You could draw the function and take a look at it, but really that's not what we're doing. At this point we will be graphing functions like these, so you'll see what those look like, but that's not what we're doing right now. So again, go through, do your derivative, and then you can go ahead and plug that value in at the end. Okay, so again, I'm going to run through this one. This is a polynomial one. We haven't done these in a while. In fact, your notes on this were before break, so I just want to run through it, go through the steps in a polynomial, and then the last ones are, the last two on this notes page are review, and you can, again, pause the video, work on those, come back and revisit when we're done. So I'm going to change my pen color. This one is f of x is x squared plus 8x minus 15, and f of x plus h is x plus h quantity squared plus 8 times x plus h minus 15. Remember that x plus h is, or quantity squared is x plus h times x plus h. Then I distribute plus 8x plus 8h minus 15, and when I multiply that out, I get x squared plus 2xh plus h squared plus 8x plus 8h minus 15. I've done all the preliminary work. Now I can go ahead and plug it in, and I will do the derivative. F prime of x is equal to the limit as h approaches 0 of this big long thing, x squared plus 2xh plus h squared plus 8x plus 8h minus 15 minus the original function. I'm just going to subtract it right away, so I'm going to change all my signs right away. So minus x squared minus 8x plus 15. Again, because it's subtraction in the thing, I took a shortcut and I distributed the negative right away throughout that. And then this is all over h. And right away things should start to cancel out, so I'm going to grab my cancel out pen. X squared minus x squared, I have plus 8x minus 15 plus 15, and so when all is said and done, I have the limit as h approaches 0 of 2xh plus h squared plus 8h all over h. I can factor an h out of that. The limit as h approaches 0 of h times 2x plus h plus 8 all over h. There I get rid of the culprit. The h cancels off the top and the bottom. And then I can take my limit as h approaches 0 of 2x plus h plus 8. That goes in for h. That's going to cancel that piece off. My derivative is 2x plus 8. But I want to find f prime of 3. Again, that goes up to here. I'm finding the value at 3. And so this is 2 times 3 plus 8, or 14. So that means at this point, the function must be increasing, because it's positive, at a very fast rate, because this is a really steep slope. Okay, so I'm increasing at a fast rate, so I have a slope of 14. So this would be a really steep positive slope of the function at that particular point. Again, that just tells me that at that point the function is going up. There's my curve, it's going up, but it's very, very steep or very fast at that point. Again, here's a spot where I'd like you to pause the video, see if you can work through the derivatives on the next one, and then we'll come back in, do them both. Like, just take the time and do them both, and then turn it back on, and we'll do the last step on both of those together. Welcome back. So I finished up mine again, went through that whole process. If you need to, if you didn't end up with what I ended up with, maybe just pause the video and sort of follow through, see if you can. I know that gets a little bit messy, but give it a try. And then we're going to go ahead and take that final step where I evaluate at, in this case, -2, because that's what they gave me up here. That means I plug in -2 for x, so I get -4 times -2 squared plus 16 over -2 squared plus 4 quantity squared, and then I'll go ahead and evaluate that. That is 4 times -4 would be -16. That's going to give me 0 on top. And then on the bottom, when I evaluate that, I'll get 4 plus 4, which is 8 squared, 64. It doesn't matter what the bottom is. My slope is 0. That means at this point, this graph must be changing direction. So my tangent line at that point would be that flat sort of line. So the function must be increasing to decreasing, or it could be the other way. Maybe it's decreasing to increasing. It could be that one on the bottom there. But it just tells me because it equals 0, the slope of the tangent at that point, that must be a point where it's changing direction. So that's what our slope of our tangent line tells us, and that's how we're going to be using it in graphing. It's going to tell us where the graph is changing direction. Okay? So last one, problem number 4 on this particular section. Same thing. I went through, I did my work, I ended up with my derivative right here as this one in simplified form, and now I'll get my final step where I plug it in. That's 1 over the square root of 2 times 1 plus 1. That leaves me with 1 over the square root of 3, which would be the square root of 3 over 3 for my final value. And now that one's not a super easy one to tell what it looks like, but I can tell it's positive, so it is increasing at that point. It's a positive slope. I could get a decimal equivalent to that if I wanted to figure out about how steep it is, but again, that's not necessary for us to do right now. But that's the gist of this part when I'm finding it at a value. But we're also going to take that one step further, and that brings us to the next side, the last examples that we have here. And that is where we're actually going to find the equation of the tangent line. So again, I'm going to have you go ahead and find the derivatives. So pause the video and find the derivatives, and then meet me back here, then rejoin, and then we'll go through the last step. So you're going to take those next 4 and find your derivatives. I will see you or meet back here shortly. Welcome back again. So I found my derivatives. I'll just go through the answers. For the first one, I got my derivative f prime to equal -4x over x squared minus 1 quantity squared. For number 6, I got -1 over x plus 2 quantity squared. For number 7, I got just -4x, and for number 8, I got 2 over the square root of 4x plus 5. So now I want to take it from there. You hopefully used your definition of your derivative to find your first derivative, and all of these functions started with y, so I just want to bring this back up again. We could also, instead of writing f prime of x, we could write this as dy dx. The derivative of the y function with respect to x is what that stands for. It's -4x over x squared minus 1 quantity squared. Well, I need to find the slope of the line tangent, and I want to find it in slope-intercept form. That's what it's asking me to do. Well, slope-intercept form is kind of a blast from the past. That's y equals mx plus b, which means I need a slope and a point to be able to do this. A lot of times I use something called point-slope form to help me. In fact, I like point-slope form a lot. Because it gives us all the information we need for a line. It gives us a point and a slope. And point-slope form looks like this. Y minus y1 equals the slope times x minus x1. And so if I have a point and the slope, I can write the equation of a line. And then I just need to move it around to get it in slope-intercept form. So what do I have here? I have a point, and I'm soon going to have the slope because I'll find the derivative of y with respect to x at x equal to 3. That's my x value here. This is my x1, y1, and my x value is 3. So I will plug that in, negative 4 times 3 over 3 squared minus 1, quantity squared. That gives me negative 12 over 9 minus 1, which would be 8 squared, 64. When I do the math on that one, I'm going to reduce that. It looks like I can divide by 4, so I think it's going to be negative 3 over 16. So that's now my slope. And again, that's what I need for this form of the line. I need a point and a slope. I've got my point, I've got my slope, now I put it together in that equation of the line. So it's y minus y1 equals the slope times x minus x1. And now again I go back into algebra because I want it to be in slope-intercept form. I need to clean this up, so I'm going to have to distribute and then move that 1/4 over. So y minus 1/4 equals negative 3/16 x plus 9/16. And so I'll add the 1/4. Adding 1/4 is the same as adding 4/16. I'm just finding a common denominator right away. This is y equals negative 3/16 x plus 13/16. And there is my final answer, my equation of my tangent line in slope-intercept form at this particular point on the graph. Okay, again, I'm going to go through that process using point-slope form for the remainder of the problems on here. So this is f prime of x is negative 1 over x squared. Again, that's dy dx. It doesn't matter if you write it that way, but I'm interested in it at x equals 1 because that is what my point says. 1 is my x value, so this is negative 1 over 1 plus 2 squared. Do my math, negative 1/9. Now that I have my point and my slope, I can put it in point-slope form, and then I can move it around to get it in slope-intercept form. So this is y minus 1/3 equals negative 1/9 times x minus 1. Go ahead and distribute and add the 1/3, which is the same as adding 3/9. Just getting a common denominator. You can use your calculator and do this too, whatever you need to do. Y equals negative 1/9 x plus 4/9. And there is my, again, final equation. We're going to run through that process again with the last two. And again, I already found my slope on those. If you ever need to pause and go back and look at the math or whatever, or just come on, I'll be hanging out and on that in the classroom or in our meet area. If you have a question about anything that we did, you can just kind of come back and talk to me about it, or pause the video and come and talk to me, and then just kind of continue on from there or whatever. But again, I have my point given, my slope dy dx, in this case at x equals 1 again. That's negative 4 times 1, or negative 4. So now I have my slope. So I put it in y minus y1 equals my slope times x minus x1. This one's kind of nice. Looks like I'm done already. My math was very easy. It was a polynomial. Everything came out nice. When I have the fractions, that's when I have to do a little bit more work. Okay, so we're down to our last one. Same thing. I'm going to, here's the point that I'm going to use. I'm going to find my slope. I did the definition of the derivative to find the formula for the slope of the tangent line. Now I'll plug that in, dy dx. Another way of writing f prime. Don't overthink it. At x equal to 1 again, this is 2 over the square root of 4 times 1 plus 5. 2 over 9, square root of 9, that's 2/3. I like it when it comes out nice. It's not always going to. We'll just have to do some different, simplifying in our math, but it did this time, so yay. So this is my slope. I'll plug it in my form, y minus y1. Again, that comes from this point. It's x1, y1. So y minus y1 equals the slope times x minus x1, and do my math. 2/3 x minus 2/3. Add the 3. 3 is 9/3. Finding a common denominator, y equals 2/3 x plus 7/3. And there is my equation. Oops, gotta raise that up. There's my equation of my tangent line in slope-intercept form. All right. Again, then you just need to work on your homework. And if you have any questions, like I said, I'll be hanging out on the Meet until the 50, until we get to our hour 50. But then after that, if you have any questions, you can just email me. All right. I will talk to you later then.